Today we learned about functions. Functions are a special type of relation where each x value matches with only one y value. So we say that for every x, there is exactly one y. And sometimes we just refer to it as an equation that works. So what do we think about when we think of a machine that works? We have our input, or our x. Then we have the equation, or the machine. In this case, it's a toaster. And then we have our output, y. It's very clear to us when a machine works. If we put in bread, we expect toast. So in the real world, when we have an input, x, of bread, and we put it into a toaster, and we get an output of eggs, this function does not work, and it is obvious to us that it does not work. So how can we use math to make it as obvious to us that an equation is not a function? There are a few rules we have. If you go to page 14 in your notes, we go through the 4 ways that we have learned about relations so far. We know coordinates, we know the graph, the table, and the map. Now I'm going to tell you the way to determine whether an equation is a function in each one of these categories. So first, let's start with the coordinates. We can test if the coordinates are part of a function by looking to make sure each x value has only one y value. So in these coordinates here, each x value is paired with one y value. We have a 0 here, a 1 here, 2, 3, 4, and they each go to a different number on the other side. Now, if we look at the part of the coordinates that is not a function, we see 0 here, and then 1 repeats. 1 has a bunch of different outputs in this equation, and that cannot make a function. Why? Let me explain. Let's say you go into an ice cream store, and they have 3 different flavors of ice cream. Let's call the flavors of ice cream X. You look at the menu and you see the price of the ice cream, or Y. This is a pretty normal looking store. Each flavor has its own price, nothing fishy going on. Let's look at this store over here. You walk into the store, and for every X value or flavor of ice cream, there's 2 different prices here. I wouldn't want to shop at this store. How do I know how much the ice cream costs? How could strawberry ice cream cost $3 and $3.80? It doesn't make sense. You need to have one value for every, you need to have one y value for every x value. So when we go to the graph, there is something we use called the vertical line test. If a graph is a function, it will pass the vertical line test. If a graph is not a function, it will not pass the vertical line test. What is the vertical line test? If you take your pencil and you drag it across the graph from left to right, and there's no part where there's more than one. So let's look at this one here. If we have a line here, and we move it from left to right, This one is definitely not a function. I have two y values at an x here, two y values at an x here. This is not a function. Now let's look at the table. We have x here and y here. Remember, if we have more than one y value for the same x, it can't be a function. So let's look at the table here. For every x value, there is one y value. So this one here is going to be a function. Over here, let's look at this one. At 0, we have y equals 1. At x equals 1, y equals 2. At x equals 2, y equals 5. At x equals 3, y equals 10. At x equals 4, y equals 17. For every x value, there is only one y value. This is a function. If we look at the table and we see that there is, when x equals 0, y equals 3, this is good. When x equals 1, y equals 1, this is good. But x equals 1 again and y equals 11. Now x has more than one y value for 1. It can't be a function. So whenever x repeats here or here, and there's more than one y value for x, it can't be a function. Let's look at the map. If we have arrows that point from one x value to a y value, we see the x input and the y output. We can test on a map if it's a function like this. Each x value has only one arrow coming out of it. If that is true, then it is a function. Let's look at this one. We have one arrow coming out of the x, one arrow coming out of the x, one arrow coming out of the x, and one arrow coming out of the x. It is a function. On the other map, we have two arrows coming out of the same x. That means there's two y values for one x value, and that is no good. Here we have two arrows coming out of x equals 3. That is no good. Therefore, if the numbers have more than one arrow coming out of the x value on a map, we know it's not a function. I know these are very hard to see at first, but if you complete through page 18 and do the examples, you'll be able to see how you can apply each one of these 4 rules to coordinates, a graph, a table, or a map, and see if something is a function or not.